So this is the job of these two equations. Let me return back to the previous slides. So this is the this slide here is called what is the time constant. Tell you what is the time constant. Let me go back again. So the time constant for RC circuit, it is tau, that is RC, R times C, as I said before. Okay, where R, for example, if you look at this circuit here, R is the resistance between these two terminals. R is the resistance between these two terminals. C is the capacitance, which is 1/6. C is 1/6. This is C. C is 1/6 farad. So if I want to calculate R, for example, I want to calculate this tau. So first I want to calculate R. How do I calculate R? You need to calculate the total resistance between these two terminals. Let me do it here. Okay. So for example here, let's look at this. So you have this circuit. The circuit look like this. And you have this voltage source. Usually when you calculate the total resistance, you have to turn off the source. When you turn off a source, if it is a voltage source, you replace it by short circuit. So it's short circuit. You have to replace the source by short circuit. It's a voltage source. If it is current source, it's open circuit. So this is 6 ohm. This one is 12. And this one is 4. You don't need the capacitance here because you need to calculate the resistance between these two terminals, this one and this one. And if you look at this, now all these resistors are parallel to each other. Why? 4 and 12 are for sure parallel to each other. Okay, because it's very clear. They are connected to each other. We know that. Okay, both of them are connected to each other, like this. And also 6 is connected to this point here, from this side, and from the other side is connected here also. Okay, so 6 is connected to, if this is A and this is B, then 6 ohm is connected between A and B, 12 is connected between A and B, 4 is connected to A and B. Then in this case, you can calculate the total resistance like this. 1/R equal 1/6 plus 1/4 plus 1/12 over there plus 1/4. And then you can calculate the resistance R. Okay, how do you calculate it? You use a calculator here. So it is 1/4. 1/6 is here, it is 6, and you hit 1/x plus 12, and you hit 1/x plus 4, and then you hit 1/x. This will give you 0.5. So the answer here is 0.5. 0.5. And then you hit another 1/x to flip this, will be 2. So the resistance here is 2 ohm. So this is R. This is the resistance between the two terminals of the capacitor. So if you want to find tau, which is the time constant, it is R times C. R is 0.5. R times C. R is 2 ohm. And C equal what? C equal 1/6 farad. 1/6 farad. Then it is 1/3. 1/3. 1/3. What is the unit for the time constant? The time. It's a time. Time constant. So it is in seconds. Seconds. That's it. So this is the time constant here. Is 1/3 seconds. 1/3 seconds. How do you calculate it? So here, what we need to know here is when you have a time constant. Let's see here is this part here. What you can notice here is that when t equal tau exactly, when t equal tau, okay, when you discharge, the voltage is decreasing now. The voltage is decreasing. So after tau, when t equal tau, what is the voltage? The voltage is you see here this number here, it is 36.8% of the maximum of maximum. Of the maximum. The voltage is 36.8% from the maximum when T equal tau. So if you know that this is a, you are charging, for example, you are discharging here. But if you charge, when you charge, how it look like? Look like this. So if this is V0, this value is V0. When T equal tau, when T equal tau exactly, T equal tau, then the voltage here equal what? V equal 1 minus this number will be 63.2% of the maximum. Of the maximum. The maximum. Okay, so this is a definition of the time constant. So when after time constant, it will be almost 2/3 of the voltage. For example, if your cell phone, the maximum voltage is 9 volt. The maximum voltage is 9 volt. And the time constant of your cell phone battery, for example, is 1 hour. 1 hour. Okay. So this means after 1 hour, your cell phone will be charged by 2/3 of the maximum. 2/3 of the maximum, which is 2/3 of 9 volt is 6 volt. You will have 6 volt on your battery. Okay. Next one here shows the time constant for RL circuit. So it will be exactly the same, but here the same definition, but tau equal L divided by R. L divided by R. And if you want to find R here, you have to use, you have to find the resistance between the two terminals of the inductor. So here it is. You have this 5 ohm. And you have, as I said, you have to turn off the source. So the inductor is here between these 2 points. The inductor is here between this A and this B, for example. And here you have this 10 ohm. Okay. And here you have a current source, this current source. But the current source, you have to turn it off. When you turn off a current source, you replace it by open circuit. So you remove it completely. You remove this current source completely, like this. Okay. So finally, you will have this simple circuit that has only 10 ohm and 5 ohm. Then what is R in this case? R is 15, because 5 and 10 are in series. So R is 5 plus 10, which is 15. So R equal 15. Let me do it. So now if you want to calculate the tau for this circuit, tau equal what? Equal L, which is 1.5 Henry, divided by R, that's 15. 1.5 divided by 15 is 0.1. 0.1. And what is the unit for time constant? Is seconds. So this is the time constant for this inductor, 0.1 seconds. Okay, so this is the time constant for this one. Next slide here. Usually in this circuit, we'll have this kind of switches. You see this switch? So you have a switch like this. You have a switch. So for example, you have a switch like this. And you will have an arrow like this one here, for example. Okay. So what is the meaning of this? The switch here is turned what here? So this means that it was connected first on, and then after that it will be off. So according to this arrow, the switch was on like this. and then after that will be off. You turn it off. It will be disconnected. So it will move from this one to this one. So this is the explanation of this switch. It was on, and then after that will be off. Okay. If you change the position, so let's do it different way. Here it is. Same switch, same, but different arrow. The arrow in the other direction. So if it is like this means that it was what? Here. When it is like this means that it was off. It's not connected. And then after that will be connected. It will be on. Okay. So this means that it will be off first. Okay. And then after that will be on. So this means that it was off and will be after that on. First it is disconnected, and after that it is connected. But for the other one, look at the arrow. The direction of the arrow is moving in this direction. The arrow is moving in this direction. Okay, so it was on first, and then after that will be off. So it is on first, and then after that will be off. But for the other one here, this one, the switch was off. Look at the direction of the arrow. The switch was off, and it will be on. Off means open or disconnected, and on means connected. Okay, so this is the definition of this switch. So if you look at these examples here, for example, this one, if you have a case like this, the switch was in the right first, and then after that will be connected to the left, from right to left. You are moving from right to left. This means that the switch was connected to A. Let me use the laser pointer. So this point was connected to A first, and then after that will be connected to this branch here, which has a source. Okay. For example, if you have this one, this means that this switch was connected, this point was connected to this point first, and then after that will be connected to the other point, this one. This is the meaning of the switch. It's the meaning of the switch. Don't worry about this too much. So this is the definition of the switch. Then we need to go to solve some problems now. We have different problems here. They are all similar. There is no big difference. We have 2 for capacitor and 2 for inductor.